Hello, and welcome to Health Science 401 Epidemiology. I'm Georgia Halkia, and I'm going to be your instructor this semester. Just by looking at the roster, I can recognize a lot of the names, so welcome back. So I assume that you guys know me, you know my style of teaching, and you're probably comfortable with my accent for everybody else. Please know that I'm very approachable, and if you have any questions, feel free to email me or stop by my office hours, make an appointment or a Zoom conference. I'm always available for you. All we need to do is figure out a time to meet. Okay, so let's get started. So the learning objectives of this lecture is first of all to introduce you to epidemiology. We're going to define what are the goals of public health. We're going to distinguish between the basic clinical and public health research in epidemiology. We're going to define epidemiology and clearly explain its objectives. We're going to also talk about the key components of epidemiology and also discuss some very important figures in the history of epidemiology. Make a note here that I made some links available on Titanium. I'm expecting you to actually access those links and read more about those historical figures. Okay, you're going to see questions about them in your upcoming quizzes and exams. So, what is epidemiology? I know a lot of you having a hard time even pronouncing the word epidemiology. It is a Greek word after all. Okay, so probably it does sound Greek to many of you. But Greek words usually they're just composite words. So that means that like so there's the epi part, the demos part, and the logi part. You probably know that logi means the study of, demos in Greek means the study of the people, the population, and epi is literally means on or upon. Hence, the epidemiology means the study of the people. Now, what is the definition of epidemiology? So this particular definition literally comes from your textbook, and I truly think that is one of the best and most inclusive definitions of epidemiology out there. Um, Other textbooks also use Gordy's definition, so I'm expecting you to understand the different parts. So as let's read it together. It says it is the study of the distribution and determinants of health-related states or events in specified populations and the application of the study to control of health problems. Key things to notice here. So we're talking about distribution and determinants, right? So how it is being spread and what are the causes of disease, right? And we're also talking about population. So how do we define a population in epidemiology? We're going to talk more about that. And the idea is we do all that in order to control health problems, okay? So, clinical epidemiology. What is the difference in those two views of epidemiology? In the clinical setting, epidemiologic methods are used to make a prediction about a health outcome for an individual based on scientific studies of groups of similar patients. Clinical epidemiology is integral to evidence based medicine. Epidemiology itself is the study of disease in a population with goals of determining the frequency and distribution of the disease as well as risk factors for the disease. Although epidemiology is defined with regard to human populations, epidemiologic principles can be extended to the study of other problems, such as colony collapse disorder in honeybees or improving herd health for a dairy. So, what are the objectives of epidemiology? You should know those. So, it is to identify the etiology. Etiology literally means cause of disease. To determine the extent of the disease. So, how badly is it spread? Is it affects only a small city, a village, an entire state, an entire country, or the entire world? How the actual disease progresses. So, what are the different stages of disease progression? How quickly, if it causes death, how quickly that death will come, right? Because that essentially will affect how we're going to approach in order to cure or help the person that is suffering from that disease. To evaluate preventive and therapeutic measures for the disease or condition that we are concerned about, And finally, to develop public health measures, right, policies that will prevent outbreaks or the spread of disease or whatever the problem may be. As we previously said, one objective of epidemiology is to identify the cause of a disease with a desire to prevent or modify the severity of the condition. Consider this table, Table 1. Would you agree that this table accurately portrays the true causes of death in the US population? Why or why not? As you may notice, tobacco, diet, alcohol, microbial agents, toxic agents, firearms, sexual behavior, motor vehicles, and illicit use of drugs, they're all modifiable factors. The percentages do not total 100, but if these results are accurate, a large percentage of deaths can be postponed. The opportunity to prevent or ameliorate disease is an exciting component of epidemiologic study. Epidemiologists follow predetermined procedures in deciding whether to attribute a particular factor as a cause of a disease or condition. Change over time. How can have mortality rates change from 1900 to 2004? So, look at this particular graph and you can see some very important public health milestones. Okay, we can see that we have shifted from infectious diseases in the early 1900s to chronic or lifestyle diseases in 2004. So this bar graph depicts the death rates per 100,000 people. That is something that you need to pay attention because when you're going to start making calculations in epidemiology, it has to do with a specific population. So you're going to need to state for how many people are you talking about. So in this particular case is for every 100,000 people. So those percents refer to that many people. So for every 100,000 people, you have, 50 cases of diphtheria or so on and so forth. So, what are some of the things that epidemiologists get to do? One of the most common things is investigating foodborne illnesses. Once an outbreak takes place, the local health department gets involved and they try to find out what are the cause of the outbreak. As you can imagine, it is not so easy to identify what food caused an outbreak since most people shop and eat at several different places and consume different foods items during a meal. Here are a couple of examples of fairly recent foodborne outbreaks that affected more than one state. The first one, the Fox News one, it is a recall from Whole Foods supermarkets. They recalled a certain brand of cheese that led to bacterial infection outbreak and made several people sick, and at least one died in several states. The second link is about berry mix sold in Costco and caused acute hepatitis A. Hepatitis A is spread when human feces contaminated food. Apparently, before those berries were frozen, they were not cleaned properly or handled properly. Freezing does not kill bacteria or viruses. Hepatitis causes inflammation to the liver, and the severity of the disease can differ from person to person and how quickly they access quality of care. The third link is about CDC side, and it lists multi-state foodborne outbreaks investigation by year. So if you visit the site, you will see that in 2017 alone, we had several outbreaks, with the most common one being Salmonella. So what do epidemiologists do? Another important task of epidemiology is to track the occurrence or frequency of infectious diseases. We need to know what is the burden of disease in the community at any given point. The idea is to identify changes, especially increases, early enough to take measures to avoid spreading of the disease. Two recent outbreaks that affected many parts of the world were the MERS and the Ebola virus. Middle East Respiratory Syndrome, or MERS, is an illness caused by a virus, more specifically a coronavirus called Middle East Respiratory Syndrome coronavirus. Most MERS patients developed severe acute respiratory illness with symptoms of fever, cough, and shortness of breath. About 3 to 4 out of every 10 patients reported with MERS have died. MERS can affect anyone. MERS patients have ranged in age from younger than 1 to 19 years old. CDC continues to closely monitor the MERS situation globally and works with partners to better understand the risks of this virus, including the source, how it spreads, and how infections might be prevented. The second one is about Ebola. Okay, you probably remember this one. The Ebola natural reservoir has not yet been identified. Thus, the way in which the virus first appears in a human at the start of an outbreak is really unknown. However, scientists believe that the first patient becomes infected through contact with an infected animal, such as a fruit bar or a primate, which is called a spillover event. Person to person transmissions follows, and then they can lead to large numbers of affected people. In some past Ebola outbreaks, primates were also affected by Ebola, and multiple spillover events occurred when people touched or ate infected primates. Ebola is not spread through the air, by water, or, by food. So please go ahead, explore those links that I'm giving you, and you can find out a lot more about them. Populations are the heart of all epidemiologic activities. The term population refers to a group of people with a common characteristic, such as a place of residence, gender, age, or use of certain medical services. For example, epidemiologists may identify that a particular region enjoys greater longevity, and based on that finding, they may design a study to identify the cause. The cause word needs to be used cautiously since, as you learn in your 349 statistics course, there are a lot of limitations to every study. The first link talks about the use of olive oil among the Mediterranean regions and how that leads to longer life expectancies. Olive oil, in comparison with other fats or oils, is monounsaturated, thus it's less likely it will clog your arteries or raise your blood pressure, cholesterol rather. The second link talks about masculinity, Mashimo effect, and how it can become a barrier to accessing care. In both of those studies, researchers monitored populations for a certain amount of time in order to derive to those conclusions. How accurate those findings are will depend upon the type of study they selected to conduct the research. Of course, in order to find that out for sure, you need to find out the original published article and evaluate it yourself, assuming you know enough about epidemiology and statistics to assess the quality of the study. Levels of prevention. The goals of medicines are to promote and to preserve health, to restore health when it is impaired, and to minimize suffering and distress. The first and second of these goals are embodied in the word prevention, which, for simplicity, is often divided into these three levels. Note that it is a simplification, but it is a useful place to begin. Primary prevention, I'm sure you all heard of this one, is concerned with preventing the onset of disease. It aims to reduce the incidence of disease. It involves interventions that are applied before, and I emphasize before, there's any evidence of disease or injury. Examples include protection against the effects of disease agents, as such with vaccinations. It can also include changes in behavior, such as cigarette smoking or diet. The strategy is to remove causative risk factors. Primary prevention may be aimed at individuals or at entire communities. Individual approaches, such as encouraging your patient to stop smoking, have the advantages that the clinician's personal contact should be motivational. The message can be tailored to the patient, and you can support him in actually making the decision to stop. But the limitation is that your advice does not tackle underlying forces driving his behavior at the first place, or in contexts in which his behavior occurs. His friends may continue, for example, to smoke. Therefore, a community or population approach, such as mass media advertising, increasing taxes, or banning smoking in public areas, these are other interventions that essentially can impact entire populations. It is more radical and may produce cultural and contextual changes that may support individual efforts. Secondary prevention is concerned with detecting a disease in the early stages before symptoms appear and intervening to slow or stop its progression. The idea here is to catch it early. The assumption is that the earlier intervention will be more effective and that the disease can be slowed or reversed. It includes the use of screening tests or other suitable procedures to detect serious disease as early as possible so that its progress can be arrested and, if possible, the disease can be eradicated. An example would be the pap test to screen for cancer of the cervix, or a PSA blood test for prostate cancer. Other instances include teaching people about the early symptoms of disease so they can actually watch for it themselves. This is the task of preventive medicine. Screening is central to secondary prevention because it is the process by which otherwise unrecognized disease or defects are identified by tests that can be applied rapidly and on large scale. Screening tests distinguish apparently healthy people from those who have the disease. Tertiary prevention refers to the interventions designed to arrest the progress of an established disease. So key term here, it is an established disease, not the early stages, and its negative consequences. The idea is to reduce disability and handicap, to minimize suffering caused by existing departures from good health, and to promote the patient's adjustments to irremediable conditions. The idea is to minimize consequences. So look at this picture and tell me what you see. So there's the water running on the back. So the faucet is on, and you see two doctors mopping the floor. An obvious criticism of medical care is that it tackles health issues without addressing their underlying determinants. The pattern of health problems can be expected to continue until someone addresses health determinants. The cartoon illustrates that idea. The two doctors are so busy mopping up the spill that they neglect to turn off the faucet. Do you think that the same criticism might be made of secondary and tertiary prevention? Here's a map of the US showing the cases of gonorrhea. So an epidemiologist will be looking at this map and essentially asking those questions. Who is at risk for gonorrhea? What are the characteristics could be putting them at risk? So we know gonorrhea spreads with sexual contact, right? So probably we're talking about sexually active adults, right? And how can we prevent transmission of gonorrhea, right? So maybe promoting condom use. And as you can see from the map, the darker regions, right? So the southern states tend to be heavily impacted by gonorrhea. So the question is, well, why is that? Um, how those states differ from California, for example. This is food for thought.